So now we're moving on from exponential equations to logarithmic equations. So you can tell that something's an exponential equation because the variable's in the exponent. You can tell that something is a logarithmic equation because there's a variable in a log. So this is a logarithmic equation right here. The log base 2 of x is equal to 4. Now, before we go into the whole process of how to solve a logarithmic equation, I want to talk a little bit about step 1. Now, step 1, it doesn't matter whether it happens first or at the end. I often forget to do it first, but it says state restrictions. What are restrictions? Well, if you remember back to like a rational function, when you have a rational function, there's a restriction because x cannot equal 0, right? When you have a radical function, you can't take the square root of a negative number, so x has to be greater than or equal to 0. What are the restrictions with logarithms? Well, let's look at that. If I have a graph like y equals log to the base 2 of x, and I said, are there any restrictions on x? The first thing you'd have to remember is that a logarithmic graph is the inverse of an exponential. So it has a vertical asymptote at x equals 0. What else? Well, the graph itself is curving towards this asymptote through the x-intercept 1, 0, and then approaching infinity. Okay, so what is the domain of this graph? Well, the domain of this graph is 0 to infinity because I can't take the log of a negative number. So these are my restrictions. And remember that if I took this graph and I transformed it, if it was something like x minus 3, what would that do? Well, instead of having my asymptote at x equals 0, now my asymptote would be at x equals 3. So what would that do to my domain? Well, now I still approach that asymptote. I'd actually go through 4, 0 there, and then I'd approach infinity. But my domain would be 3 to infinity. So there's values of x that can't work in an equation because it would make you take the log of a negative number. So for this one, you'd have to pick values that were greater than 0. For this one, you'd have to pick values that were greater than 3. Now what we're going to do is we're going to look for solving logarithmic equations. And what that is that instead of a y, we're going to put a number. So instead of saying y equals log to the base 2 of x, we're going to say, hey, when y is 4, what x value gives that to me? And we're going to solve for it, and we're going to make sure there's no extraneous solutions. In other words, a solution that appears as a solution but doesn't actually work in the equation. So to do this, we can state restrictions first, and then we can go through our steps. So let's talk about the restrictions in this first equation. So if I was to state restrictions, now there's 3 logarithms here. I have the log base e, which is ln, of 4x plus 6. I have the ln of x plus 5, and I have the ln of x. So each one has its own restriction. In other words, 4x plus 6 has to be greater than 0. I can't take the log of a negative number. So what would that mean? Well, 4x has to be greater than negative 6. X has to be greater than negative 6 fourths, or 3 halves, negative 3 halves, or negative 1.5. Okay. Second restriction is that x plus 5 has to be greater than 0. So x has to be greater than negative 5. And then the last one is that you can't take the log of a negative number. So x has to be greater than 0, and that would be itself. So when you look at these 3 restrictions, this one says that x has to be greater than negative 1.5. Well, there's 0, there's negative 1.5, and there's negative 5. So x has to be greater than negative 1.5. Cool. X also has to be greater than negative 5. Okay, well, if you're greater than negative 1.5, you're greater than negative 5, but it also has to be greater than 0. So we always look at the most restrictive. So the most restrictive is this one. X, the answer I get has to be a value for x that's greater than 0. Now, if none of that made sense to you, don't worry. You can still reject solutions another way, but I just wanted to show you right off the bat. Okay, now let's go into the process of solving. To solve an equation that has a log equal to a log, you're allowed to drop your logs. Now, this rule only applies. So in other words, if you have the log base a of 4, actually let's just say the log of 4 equals the log of x, right? Then we can drop our logs and say that 4 equals x. Okay, that's what I mean by dropping our logs. But it has to be a log of a base equal to the log of that same base, because then we've already taken care of that being equal. All right, so how do we do that? Well, if you look here, you have 2 logs. You have the log of 4x plus 6 minus the log of x plus 5 equal to log of x, right? Log of x, one term. So how do I make these 2 terms into a single logarithm? Well, I use my rules. Because I'm subtracting, I'm going to change it to a division. So division. So division goes with subtraction. So this would be the ln of 4x plus 6 divided by x plus 5 equals the ln of x. All right, so now I've used my properties of logarithms to write the equation as a single logarithm equal to a single logarithm with the same base. And they won't trick you and do different bases. You just want to make sure they're the same base. Now I'm allowed to drop my logs. So instead of having a log equation, I'm going to have 4x plus 6 over x plus 5 equals x. What type of equation is this? Well, I've gone from a logarithmic equation to a rational equation. So I got to dig back in the recesses of my brain. How do I solve a rational equation? Well, I get rid of the fractions. I multiply both sides by the lowest common denominator, x plus 5, and I simplify. I'd be left with 4x plus 6 equals x times x plus 5. Now if I multiply this through, I get 4x plus 6 is equal to x squared plus 5x. What type of equation is this? Well, it's quadratic. How do I solve a quadratic equation? Well, I have 4 options. I can factor, square root method, complete the square, or quadratic formula. Most of these questions, I haven't found one in the textbook yet that can't be solved by factoring. So to solve by factoring, we're going to set it equal to 0. So we'd have x squared plus x, because we're subtracting 4x, minus 6. So to factor this, I'm going to factor to 2 binomial brackets, x, x. My two numbers that multiply to give me negative 6 and add to give me 1 are 3 and negative 2, which means that x equals negative 3 and 2. Now these are possible solutions. So just because I solve for it doesn't mean that they're true. Okay, now how do you tell? Well, 2 ways. I can go back up here and be like, I know that the x value I solved for had to be greater than 0. So I know because of my restrictions that I could reject negative 3. And I could say, okay, well 2 is greater than 0, so 2 should be my solution. If you want to be doubly sure, you plug it into your calculator. So to check, you plug in the ln of, let's try negative 3. 4 times negative 3 plus 6 minus the ln of negative 3 plus 5. Does that equal the ln of negative 3? Well, right away, if I touch my calculator right here, I can see that this is error, right? Right away over here, I can see that this is the ln of negative 12 plus 6 is negative 6 minus the ln of 2. Again, error. Error means that you are going to reject that solution. So in some ways, I guess it kind of makes it true, but not in a way that is actually solvable. And so that's what a possible solution is that it's something that like in theory could make it true, but in practicality, you can't take the log of a negative number, so it's not true, right? Because if I look at the properties here, I get ln of negative 6 divided by 2, which is ln negative 3. So like technically, ln negative 3 equals ln negative 3. Technically that's true, but I can't take the log of negative 3. And so that's why we reject it as a solution. So to be able to tell that something is, you know, correct but rejected is that it'll make your equation true, but it won't work. Okay, its functionality is wrong. So when we check negative 3, it didn't work. And now let's check 2. If I plug in 2, I get the ln of 4 times 2 plus 6 minus the ln of 2 plus 5. Does that equal the ln of 2? Well, let's check. This would be the ln of 8 plus 6 is 14 minus the ln of 7. All right, that didn't come out very nicely, did it? The ln of 7, which if I keep like simplifying, I would have the ln of 14 over 2. Sorry, 14 over 7, which is the ln of 2. So this one's correct, right? But I could also just plug it into the calculator right up here. And so that doubly shows me that 2 is a solution, that the negative 3 is a good solution, like it's a possible solution, but it gets rejected. All right, let's move on to the next one. So can we do this one? Well, let's start with our restrictions, okay? Restrictions are that you can't take the log of a negative number. So here we've got 1 minus x. So 1 minus x has to be greater than 0. Now to solve this, if you wanted to, you could subtract 1 and get negative x has to be greater than negative 1. And then you'd have to keep going. So divide by negative 1. I get x. Be careful, when you divide by negative, you have to flip the sign. Right? X has to be less than 1. I could have done that straight away by just adding x and saying x is less than 1. Okay, so this is one of my restrictions. X, I have to pick an x value in here that's less than 1 to make sure that I'm taking the log of a positive number. The other restriction would be that 3 minus 2x has to be greater than 0. So this one I'll just do that way. I'm going to add 2x, and then I'm going to divide by 2. So this tells me that x has to be less than 3/2. The last one is already 15. Well, 15 is greater than 0, so it's good, right? That's an identity. It's a true statement, so no value of x is going to make that not true. Now, which of these is the most restrictive? We've got 1 and 3/2, or 1.5. You have to be less than 1 or less than 3/2. The most restrictive is going to be less than 1. So this is what I'm looking for. Okay, now I want you to pause the video and I want you to try this one. So apply your properties of logarithms to write this as a single logarithm equal to a single logarithm. Remember, addition goes with, think about flipping it on its side, it goes with multiplication. Okay, pause the video. So hopefully you gave this a go. First thing I'm going to do is write this as a product. So the log base 4 of 1 minus x times 3 minus 2x equal to the log base 4 of 15. Since these are both log base 4, I'm allowed to drop my logs. And so when I drop my logs, you drop the base as well. So I'd be left with 1 minus x times 3 minus 2x is equal to 15. All right, now I've changed this from a logarithmic equation to an exponential equation. It's not an exponential, quadratic. So now I'm going to simplify by multiplying through. So I get 1 times 3 is 3. 1 times negative 2x is negative 2x minus 3x plus 2x squared equals 15. Now again, I'm assuming this is going to factor. So I'm going to put 2x squared minus 5x, and then I've got 3 minus 15 is negative 12. And then I'm going to factor. Now, if you don't like factoring, feel free to use the quadratic formula, right? But I'm going to factor it. So I'm going to leave for two numbers that multiply to give me negative 24 and add to give me negative 5. So that'd be 2x squared minus 8x plus 3x minus 12 equals 0. Now I'm going to factor by grouping. I get 2x times x minus 4. And I'm going to factor out a 3. I get x minus 4. My two brackets are x minus 4 and 2x plus 3. Which means my possible solutions are that x equals 4 and x equals negative 3/2. Now, if I go back to my restrictions, x had to be less than 1. So in this one, I'm actually rejecting 4. People get in this habit of always rejecting the negative answer, but that's not always the case. In this one, I'm going to reject the 4, and I'm going to say that my only solution is negative 3/2. Now let's check negative 3/2. Let's just practice that because this one is a bit weird to check. So if I was checking this one, I have the log of 1 minus, now I'm going to put in negative 1.5 because I'm using a calculator, plus the log to the base 4 of 3 minus 2 times negative 1.5. Does that equal log to base 4 of 15? Well, if you're plugging this into your calculator, so these are log base 4, this would be the log base 4 of 2.5 plus the log base 4 of 6. Does that equal 15? Well, you could actually simplify, right? So 2.5, let's check it. 2.5 times 6 is 15. So this is log to base 4 of 15. So that's one way of checking. The other way is plugging into your calculator. Now remember, if you're plugging it into your calculator, you're going to plug in log of 2.5 divided by the log of 4, because you're going to use the change of base formula, plus the log of 6 divided by the log of 4, gives me 1.9534. 9534. I'll also put in here log to base 4 of 15. So you can check it like that, or you can plug it in. And if I plug in log to base 4 of 15, that would be log of 15 divided by the log of 4 is also 1.9534. 5, 3, 4. Okay, so I'm good. I checked it and it's good. And again, if I plugged in 4, I could see right away that it'd be the log to the base 4 of 1 minus 4. So it'd be the log to the base 4 of negative 3. And I know that's going to give me error. So I know I have to reject it. But again, it'll make the equation true in a way, but not in a way that makes it right. Like it's not actually an answer. Okay, so that's part 1. Go and practice a few of those where you can make it a log equal to a log and drop your logs. Good luck.